Good morning. I'm Dr. Jyoti Kumar. Today we will discuss about the topic basic operational concepts. It's a typical instruction: add R naught comma LOCA. Add the operand at a memory location LOCA to the operand in the register R naught in the processor. Place the sum into the register R naught. The original content of the location, memory location LOCA are preserved, and the original content of R naught is overwritten. The instruction is fetched from the memory into the processor. The operand at location LOCA is fetched and added to the content of R0. Resulting sum is stored in the register R0. This is a simple representation of the connection between processor and the memory. In the processor, we have memory address register, memory data registers, and control unit ALU, and general purpose registers, and includes instruction register and a program counter. So the instruction register contains a current instruction, and the program counter it point out the next instruction to be executed, and the content of this instruction from the program counter is given to the MER, memory address register, where this instructions is given to the memory, and then we have an MDR, memory data register, which is going to fetch the particular instruction from the memory. And once this instruction is received from the MDR, the instruction is given to the instruction register for instruction decoding, and then it is going to again get the data from the main memory to the MDR. And once the instructions and data was received by the MDR, it is given to either ALU directly or through the register and via to the ALU for the execution. Once the instruction was executed, and it is given to the MDR or directly to the input-output operation. These are registers. Registers are fast standalone storage location that holds data temporarily. Multiple registers are needed to facilitate the operation of CPU. Some of the registers are here. As mentioned, two registers, MER and MDR, memory address register and memory data register, handles data transfer between the main memory and processor. It handles the data transfer between main memory and the processor. It holds the address, MER holds the address, and MDR holds the data. Instruction registers holds the instruction that is currently being executed. Program counter points to the next instruction that is to be fetched from the memory. General purpose registers are used to hold the data, intermediate results for operations, and they are also known as scratch pad registers. As mentioned, it's a basic operation of computer, and here is a program counter. The next instructions to be given to the MER, and the memory is going to fetch the instruction from the MER, and this MDR is going to access the data, the instructions from the memory. Once instruction was given in the MDR, the instruction is given to instruction register. The instruction register is going to decode the given instruction, and so meaning that this instruction register is going to hold the current instruction. After decoding, it is going to again send the data to the memory, and this particular data is given to MDR. So once the instructions and data was received, it is given to register, and this register is going to send the data as instruction to ALU for the operation. Once the operation was done, again it is given to MDR, and this results is stored in the memory, and again it is given to input-output operation. So this is the operational concepts of the functions of a computer. And the program gets memory through the input device. Execution of program start by setting the PC to point to the first instructions of a program. The content of PC are transferred to MER, and the read signal is sent to the memory. The address word is read out of memory and located in the MDR. The content of MDR are transferred into the AR for instruction decoding. And the operation field of instructions in IR is examined to determine the type of operation to be performed by ALU. A specified operation is performed by obtaining the operands from the memory location or from general purpose registers. Simple. Fetching the operand from the memory required sending a memory location into the MER and initiate the read cycle. The next one, the operand is read from the memory into the memory data register and then from memory data register to the ALU. The ALU performs the desired operations and send the result either to the memory location or to general purpose register. Either to memory location, I mean it directly sent to MDR or it moves to the general purpose register and then to MDR. The result is sent to MDR and the address of the location where the result is to be stored is sent to MAR and write cycle is initiated. Thus, the execute cycle ends the current instruction and the PC is incremented to point to the next instruction for new fetch cycle. So the entire thing we can refer it as operations of a particular instruction. Thank you.